I'm starting. Today, we're going to talk about performance testing specifics of Kubernetes applications. It will be a quite brief overview of testing such applications because we do not have a lot of time, and it's quite deep and difficult topic to discuss it in details. First of all, who am I? My name is Raisa, as you already know. I have 13 years, almost 30 years experience in QA. I started my career on the fifth grade of the university at Material Solutions, and I have an experience testing base stations like hardware, IP telephony, and web applications. Backend applications, mostly backend actually, my experience late here. About 5 years, I already teaching QA, I'm helping people to start their career in QA, mentoring QA engineers. And 4 years ago, I changed a little bit my direction. I changed it for non-functional testing, performance testing, and currently I'm leading the performance team. So that's it about me, and what I will talk today about. I will talk about our experience because it's a little bit specific, but I'm pretty sure that this experience can be spread to almost every Kubernetes-based applications or Kubernetes performance testing of Kubernetes-based applications. Why our product is quite specific? Because even it is, I'm talking not about the full company system, but only one part of it, messaging. But still, we have quite specific product because it's a little bit legacy. It has more than 1,000 components in production environment. It's quite a lot to support and to develop. And the main point is that we have quite strict requirements of high availability of our system. It's 5 nines, it's 99% and 99 after the dot. If you're aware of this, it actually means that we can be out of service like 5 minutes or 4 minutes in a year. It's very high quality. And it's important to say this here because you understand it later. So, and I will talk also about some assumptions that we've made, and it was a little bit mistaken assumptions. So, agenda. First of all, I will talk about what is Kubernetes, how our system looks like. Our environment, performance environment, and what issues we faced during moving to testing these applications, and what workarounds we've applied, and some recommendations on metrics if you will do such testing in future. So, what is Kubernetes? Does anybody aware what is this? Who's working actually with Kubernetes? Okay, not so much people. Okay. Who's aware what is performance testing? Okay. Should I?
Start from
Okay, then I will start with topics that I actually didn't wanted to cover. What is performance testing? Is when we have some application and we need to check. It's actually very difficult topic because the performance testing is direction of the QA, and it has its own types of testing, different stress, volume, capacity, load, and etc. It's not the whole. Longevity also, yes. When we are making load, possible load, or actual load if we already have the system run on production, and checking how system is behaving under this load, and if this behavior is suits our expectations. So if we are okay with system performance. So that is about performance testing. And what is Kubernetes? I found such meme. I thought that it's quite funny. And I'm not an expert in Kubernetes. I'm really wanted to make this statement here. I know it at the point that enough for my work. And Kubernetes, or K8s, this is acronym. Yes, this is a platform for managing and running and actually administrating applications. It allows to do like scale ups. I mean, you can scale your system from down automatically or scale it up. You can configure it to do it automatically. For example, if my system have load and after like, I don't know, 50% CPU, then system will automatically scale up, and if it has lower, then it will scale down automatically. So we actually don't have this. We do not use this this feature right now, but we are going to use it. So what it helps to reduce cost of system in production and in environments, and a lot of other things. We will not actually cover them today. What is important to say that what is difference from the, for example, hardware. When I started my career at Motorola Solutions, we have a system. We had a hardware. It was really in rack and database. We had a lab where we came to put the cables, and we tested an application about this hardware and operational system. When I started my career at Ring Central, we already, it was these years when everybody was moving to virtual machines, and we already didn't have, we had these racks with the servers, but on these servers it was virtualization. Under this virtualization, we had a lot of applications. So and we started to work with virtual machines, and actually in working it was almost the same, right? But when we are talking about Kubernetes, and actually this information is taken from the official, this picture particularly is taken from the official Kubernetes documents. You can go through it. It's very helpful. And when we're talking about Kubernetes or containers, we have the hardware. Under this hardware, we have operational system. Under this operational system, we have a containerization system. Inside it, we have containers. And inside the containers, we have applications. Important words we should also discuss to understand the next slides. It's what is Kubernetes cluster inside. So inside we have physical CPU, physical memory, physical network. Inside the cluster, we are operating with such names like nodes. It's actually, we can compare it with virtual machines just to make our understanding simpler. So inside the node, we have virtual CPU, virtual network, virtual resources, every resource that we have. And inside the nodes, we have pods. Actually, one pod, it's an application. We also have infra node. You have it on the slide, and this is for some, schedulers, for something, infra stuff. Inside nodes also we have like util pods. There's some processes that, for example, coordinates, logger, and such processes that helps to work our applications. So the main point is that we have like 2 layers, probably even more, of resources that are shared. And to go further, let's see how our system under test looks like. And so it's not very good picture, but it still shows that we have some environment. I don't know, see for you. We have some environment. On environment, we actually have more than 100 components. It's actually 126 or even 130 of real production. Because it's performance environment, it's quite big, so we should have such results that we can extrapolate to production. We have more databases. Yeah, I didn't show them here. It's about 30 unique components, and all moved to they were on virtual machines, and we moved them in Kubernetes. Also, we have some automatic tests, performance tests that are written in Gatling, and quite huge automation there, including reporting, including starting environment. So we have automation that starts environment from scratch, even on virtual machines. We had it like this to reduce costs, not to waste them. So before each run, we started our system even on virtual machines automatically. Then we check the environment because when it started from scratch, we do not sure that everything configured was okay. So we are checking it. Then we are running warm-ups to warm-up caches on databases. After that, we are running the test that for some time, yeah. And after that, we are turning down the system. So what was our expectation that we are going to Kubernetes and we are happy. We now have a cost reduction. Everything is working. Everything automatically scales up, scales down, and so on. But actually, adopting new technology like on this meme, it's not like an easy and even if they told so. Issues that we faced. First of all, we write it all. As I already said, we have a lot of automation, and with the new technology, we had to rewrite a lot of part of our automation and actually an approach to this automation. Because now stop and start environment using, we need to do it using special Kubernetes libraries, Kubernetes API. It has its own issues also, but also we need to revise our approach to check environment because now it doesn't work as it used to. Next is, I named it like a funny name, so guess my name please, because when we are talking about virtual machines, we have every time, okay, I will step back a little bit. When we have a virtual machine, we have its name. It exists all the time. So it has the static name, static IP actually also. And when we need to check it, we can name it by name. It's easy. So, and our reporting system, okay, and in the cluster, we do not have such feature because cluster exists, but these pods, these applications doesn't exist before you start environment. They are starting with starting environment, and we do it like 5-6 times per day, and each time we have new applications names. I mean unique, yes. So to find it in this virtual space. So why it is a problem? Because as I already told, we have automation. We have automatically gathering and comparison of the metrics. So we gathered metrics from each host, unique host. I mean per host. If you have 100 plus applications, so that means from 100 plus applications, from each host we gather metrics for the period of performance test. We are aggregating them. After that, we're aggregating them between component and making stats analysis automatically. So in the picture, you see that it's an example. these calculations we are comparing between previous release. So we're gathering them from the previous release, we're gathering them from the current release, and comparing. If they are okay, then performance is okay. If you are talking about Kubernetes, the host names are changing now every time, and we need to rethink how we are comparing these metrics. Do you have any idea how it could be done?
Labels.
Labels of what?
Provide special label on the stage of deploying static virtual machine. So mark somehow each application, each one.
Yeah, probably it could work. But what we made, we started gathering a range. So we do the same work, we're analyzing per pod, but now we are not targeting to this pod. To this direct machine. So we are gathering from each pod these metrics and making from them range. Actually, it's a better approach, I suppose. I like it more. We use it now almost for every metrics in our system, and now we are comparing if the metrics that we received are in the range. And if you are attentive enough, you see that 9.5 is not in the range, but it's market is okay. So above this range, we have 5% more, like 5% fluctuation, not to have fluffy results. Flaky results. Because 5% that's okay for us. So if we have 10% degradation or degradation when we are working worse, yes, and or better, it's a problem for us because something changed in the system and we don't know what, and we should understand what. So this was the first one. Now it's like it's easy to talk about. It's not easy to implement. The second issue is how many nodes. As we already talked, that it's all the time it's scaled from 0. And the first issue that we faced that pods starting allocating to the nodes before all nodes are up. What it means? It means that the first started nodes will be overloaded by the applications, and the last two will be not loaded at all. So it's not good for us, and it's not prod-like actually, because we do not start from scratch for the production. We have distributed load in production, and we should have the same in our environment. And the second is such an approach of Kubernetes that applications have their own requests and limits, request limits. It's resources that application needs, and they are scheduling on the nodes according to these request limits. As you already told that not everybody aware what is Kubernetes, I will just share what is it. Requests actually can be compared to the minimum resources that application is required, and limits is maximum resources that application could take. If you are hearing attentively, what it can lead to when we're scheduling in such way. In terms of performance, where we can come if we use such approach. So request is the minimum resources, limits is the maximum resources that each application can take, and scaling, on each node, applications coming according to requests. So, for example, my node has 10 something, and my applications, 2 applications, one is required, for example, 5, and then other 5, it's requests. Then they are going to this node. It's okay. They are suited on this. But the limits are like for one application it's 6, and for another is 9. So it means that if applications really loaded, then the node cannot provide these resources because it doesn't exist there. So it doesn't exist there. You can actually also, I link it here, the links. You can check it later to expand your knowledge. So what was our solution? Here we are waiting while all nodes up, and only after that we are scheduling pods on them. In such way, we have like a normal distribution between nodes, and it makes our life a little bit easier. So it's important to mention here that we will almost never have such a situation in production when they started nodes from zero. We also fixed the count of nodes for performance testing only. It's not a good approach for production, definitely, because in production we should have this. It's actually advantage of Kubernetes that we can scale up system when we need it. The third issue, who is on the pod? It's everything about resources. That's why I, in the first talked about resources. I want to emphasize this. As I already told, pods are allocated on nodes according to resources, but they do it randomly. What does it mean? It means that pods has different requests and different load. They can be loaded, they can use high CPU, they can use, why it's an issue, I'm already explaining. They can be low load, they can have lower usage, they have, some of them can have a lot of network usage. And the main point of this is that they are actually conquer on the common resources. And it's basically CPU, memory, or network. So if one application on this node overloaded, it can influence others, and etc. In performance testing, it leads that every time you're running performance tests, you're comparing to the previous release, you have actually every time different environment. And it's not quite easy to compare such results. And I want to show some cases because, again, 2 years later, 1.5 years later, it looks like an easy information, but we spent quite a lot of time of our team, of our department, to investigate all of this, to understand how it actually works. Heavy pods affects all other pods on the node. It was proved, and it is like this because of resources. And the applications, yes, that was the first point, yes, that applications request something, but they couldn't take even their request because of the other application uses all the resources according to the application's limits. The second case is we on the node also, as I already told, have something like, I called it util processes like logger, core DNS, and so on. And this is also on these shared resources. And if one application uses, for example, logger, we had this. It was like in the bug level, and it was like high usage of logger. This also affected all the nodes on this application. when I'm talking about the node, we do not consider like 3 pods. Yes, we consider it's 13, 15 applications. It's really, it could be different applications, or it could be instances of the one application, and it's every time different. So, but what is not like obvious, it's when different applications uses this locker normally, but they are a lot. It also can influence the all node performance. And the third issue, I called it mystery issue with latency degradation. Why so? Because we spent like a year to investigate this. And I found the answer actually unexpectedly. I will show. So maybe two small picture. So this is like an example of the test. Okay, the part of test report, and this is a report for applications that are run in the Kubernetes, and we have like one run is okay, the another is not okay. One run okay, another like every time, and we couldn't understand what is going on. And for example, such this is from the bad report. We have in the last column we have 50% percentile. It means that 50% of requests are slowed down, like on 10%, on 8%. Okay, you could say that it's not a lot. 1-2 milliseconds is not a lot. But when we are looking at the 95% percentile, it means that 95 requests are slower on almost 200%. Is quite a lot. And considering that we do not have real production environment, because we couldn't have it in our test, we actually nervous here because it's not okay. We started investigating. Okay, it's like easy on our reports. What we see, we have we are going to this to the main application that is proper. I forgot the word. That is these endpoints used this company.
API
Huh?
API gateway.
No, I mean all the requests going through this component. So we are going on this application. This is like the main application, and we are seeing here that this is pods, right? Some pods are okay, and some have response time degradation. Okay, why? We have a question. Why? We should understand why. We are going to the CPU, and we see that also the same for CPU. But why? We are going to the request rate. It means how many requests were on these pods, right? This is the first guess that is coming. Probably they had different load. We'll see that not, and the load is the same as it was in the previous run. And through several thousands. Okay, it's a joke. Through the several runs, we knew only one thing, that all endpoints on our system are degraded. In case of high CPU, even on one or several nodes, between several nodes, and we have like 11 nodes. So it's not so much, but why? We really wanted it's probably not so important to have this 1-3 milliseconds, but if we do not understand something in the system, it means that it can be something in production that we even couldn't fix. And our architects and the team, we as performance team were like saying that we see this, we have costs, the CPU or not, and we have influence on the latency. And so they in the Minikube, it's like a local environment, they they wrote an application that didn't do anything. It's just take the request, no calculations there, and sending the response. And they started this application on Kubernetes and started some other tools to eat CPU on the node. And they proved, and you see on the graphics, they proved that even when we have 30% of CPU usage, it's not a lot on the node, we have CPU degradation. We have latency degradation, even on applications that doesn't do anything. So we proved it, but okay, why you want to do with this? And next week or 2 weeks ago, I was on the AWS Summit. Probably some of you also were there. And I was on the performance topics, and I stayed. And from nowhere, it appears this picture. Even in Hebrew, I know Hebrew not very well. I get what it means, and that is my answer, because they are. The statement was that the instances that you see this in VS as 86 C6I, and this is instances that we are actually using. They proved that they have latency degradation if CPU reaches 60%, and it's very interesting, and we actually haven't right now time to prove it, but I'm pretty sure that it will help. So we are going to test our system on gravitons and check this. So
Yeah, I have a question. Was the latency degradation like continuous? Did high loads like cause it to break down even further, or did it like get a little bit worse and then it stopped?
I suppose it was continuous, and to make this statement, we need really to check. So, but I suppose that it's continuous, and it will be limited by the resources eventually. I mean that there will only be any others. I suppose. I mean that the system will reject such requests. I mean the clients. Because if we have degradation, so we have timeouts on the system, so they will be timeout.
At a certain frequency, their paths will be rejected. Certain latency.
Yeah. So what is our solution here? It's not solution for production, right? Yeah, I think you understand this. So, but actually, this is the first one is for production also. We monitor our runs. Okay, we did it before, but we now monitor and rerun such badly, as we called it, badly spreaded pods. So we monitor pods, we monitor cluster, and if we see that we have not equal spreading, then we rerun, restart environment, rerun, and something like this. We moved heavy pods to separate nodes. It's actually not in performance environment. We do not do this, but in production, we've made it for several applications, for one, probably for two. Because it's important for us, so we know that they are heavy and they should work and not affect another one. And this is an idea. I couldn't call it like best practices because we still don't have best practices for this technology, I suppose. But the idea is to split components, applications, pods on such groups, like when we have applications with critical latency, or we have low loaded or heavy, and to make them separate groups and to have for them special space in the cluster. So it was just like an idea, and we are working on them, I suppose. And from the testing perspective, the last one it's changing tools. So I want probably like to make this statement that Node is not actual virtual machine. So you cannot just connect by SSH to it and to do something, to see logs or something like this. And the pod also is not a virtual machine. What it leads to RCN. You cannot connect to SSH to check something, and you cannot use such tools like TCP dump, IP tables, or profilers for performance environment. Actually, you can. They have substitutes for this. You have special tools for it. You need to learn these tools. But according to TCP dump, what I want to emphasize that when you are running a performance test and you also running a TCP dump tool on the node, this node will be degraded. So and because of this TCP dump, it uses a lot of resources. So you need somehow also to be aware of this. And we're actually on this road, so we're still trying to use some tools. So we're learning and so on. So this is probably it. Useful metrics to gather. It's not a recommendation. It's just our experience. It's important to gather all cluster metrics like nodes count, so how many nodes run, was they run actually, yes, so that they weren't restarted during the test. Pods also, okay, pods wasn't restarted. How many pods on these nodes, and actually the set of this pod. So to find the heavy pods, you need to understand who is the heavy, and resources like CPU, memory, network, and also it's important to monitor what util processes like logger, coordinates, etc., to see that they are using a lot of resources, for example. And it could be also the recommendation or like alarm to development team that we need to do something with usage of the logger. Actually, we have. I'm not talking about something that we do not face. So we have this issue with Logger, and the developers worked a lot to fix the Logger, to fix the applications, to use it correctly. And according to CPU, I'm listing here CPU waiting times, throttling, and switching context. It's important to say. It's a message from the developer of our department that just CPU usage is not enough for the Kubernetes. It sometimes doesn't show the spikes in the actual picture of CPU usage. You need another metrics. And he wrote an article, and you can read it if you want. It has I have it in the links. So the summary, the main summary is that you have to prepare your performance infrastructure, your tests, your frameworks to work with the new technologies. In this case, with Kubernetes, it's not just we change something and do not do on this side. We need a lot of work to do on the testing side also. Upgrade monitoring to monitor cluster properly. And okay, now there are a lot of articles I googled because I googled 2 years ago and I googled now. And there are a lot of articles now for this topic. I have also in the links in the resources. It also my colleagues shared with me the website of like big companies usage of Kubernetes and issues that they faced. It's quite interesting website. I recommend to go through it if you will move to Kubernetes or use Kubernetes. Remember that resources are shared, and such thing is a problem for performance analysis, and you need to learn how to work with these different distributions and different results. And it's not for performance, but performance can be commented here. It's meaningful to have meaningful requests and limits for applications, and not only Kubernetes to blame, right? Like in this case, where actually it was Amazon instances who were guilty for this latency degradation. That's it from my side. I have links here I could share after. And thank you. I'm happy to answer your questions. And please connect with me. It's LinkedIn and my professional personal Instagram. So if you have questions, I'm happy to answer. Any questions?
Now everybody know what is Kubernetes and K8s.
X.
That's 7, 8, 7. Yes, yeah. Okay, guys, move on and let's talk about little bit about